Video is about problem solving with stationary points. Let's start with functions which don't have a turning point. To locate turning points, we generally let dy dx equals to 0 and then solve for x. So what do we do if we're presented with a function and asked to show that it doesn't have any turning point? Well, if it doesn't have a turning point, then it must not be possible for dy dx to be equal to 0. Let's look at an example of a question like this. So in this example, we have y equals 3x plus 5 over 2x minus 3, and we want to show that this function has no turning points. So our first step is going to be to find dy dx. And to do this, we'll have to use quotient rule in this case, which is given to you in the log tables as v du dx minus u dv dx over v squared. Here I've identified u and v, and at this point it would be a good plan to pause the video and then find du dx, dv dx yourself and sub them into the quotient rule formula. Okay, so in this case, du dx is going to be equal to 3 and dv dx is 2. So let's fill that in for dy dx then. So that'll be v du dx minus u dv dx over v squared. And at this stage then we're going to tidy up our numerator. Just bear in mind that it's rarely worth your while bothering to expand your denominator, so we're perfectly fine with leaving it as 2x minus 3 squared in the bottom. So take a moment to tidy up your numerator and see what you get. And we end up with minus 19 over 2x minus 3 squared. Okay, so we have differentiated, that's fine, because that's the first step towards finding a turning point. But now we want to use this information to show that there isn't any turning point. And like I said previously, this really comes down to showing that this particular value for dy dx cannot be equal to 0. At this point, it's worth noting that a over b, so any fraction, can only be equal to 0 if the two f's there just means if and only if a is equal to 0. So only if the numerator is equal to 0. So if we go back and inspect our result for dy dx here, we can clearly see that our numerator is not 0. So what that tells us is that our fraction can't be 0, which means that dy dx can't be 0, which means that I can't have a turning point. So I just need to make a note of all that now in order to finalize my question. I'm going to start by making the observation that minus 19 is not equal to 0. Pretty obvious, you might think. And this then leads us to the statement that minus 19 over 2x minus 3 squared is not equal to 0. At which point we can then state, well, that means that dy dx is not equal to 0. And then we can conclude that therefore y equals 3x plus 5 over 2x minus 3 has no turning points. And it's important to go through these steps at the end to kind of wrap it all up neatly and logically. Don't just leave it hanging at this stage here. Make sure that you explain what's going on.